Hello everyone, I'm Brandon Ordoñez from ECE41 and today I will be performing our experiment number 7 for our Data Communications Laboratory, which is entitled Design and Implement a VLSM Addressing Scheme.
Hello everyone, so now let us begin with our experiment. So for experiment 7, we will design and implement a VLSM addressing scheme. So first of all, this is our topology. It uses 2 switches and 2 routers. This will be done later using packet tracer. So now let us begin. So for the instructions, for part 1, in part 1 you will examine the network requirements to develop a VLSM address scheme for the network displayed in the topology diagram using the 192.168.33.128/25 network address. So for this, I have used an IP subnet calculator from the internet in order to gain the values needed for calculation. So now let us split the screen. First, step 1, determine how many host addresses and subnets are available. How many addresses are available in a /25 network? So it is said here that this is a /25 network. So the host bits for a /25 network is 7. So 2 raised to 7 minus 2 is equal to 126. What is the total number of host addresses needed in the topology diagram? So it says 40 plus 2 plus 25 plus 5 plus 4 plus 4. This is derived from the number of hosts required by each component, by each subnet. So 40 plus 2 plus 25 plus 5 plus 4 plus 4. The answer is 80. Next, how many subnets are needed in the topology network? So it says 6. The answer is 6 since BR1 LAN, BR1 BR2 link, BR2 LAN, BR2 IoT LAN, BR2 CCTV LAN, and BR2 HVAC C2 LAN. 1, 2, 3, 4, 5, 6. Okay, so for step 2, determine the largest subnet. Step 2, determine the largest subnet. What is the subnet description? BR1 LAN, since it requires 40 hosts. How many IP addresses are required in the largest subnet? 40. What subnet mask can support that many host addresses? /26 or 255.255.255.192. How many total host addresses can that subnet mask support? So the host bits for that subnet mask is 6. So 2 raised to 6 minus 2 is 62. Can you subnet the 190.168.33.128/25 network address to support this subnet? The answer is yes. It can support this subnet. Next, what are the network addresses that would result from the subnetting? So this is calculated using the IP address calculator from the internet. So the answer is 192.168.33.128/26 and 192.168.33.192/26. Use the first network address for this subnet. So we will use this for the subnet. Next, step 3, determine the second largest subnet. The second largest subnet is BR2 LAN since it requires 25 hosts. How many IP addresses are required for the second largest subnet? 25. What subnet mask can support that many host addresses? The answer is /27 or 255, 255, 255.224. How many total host addresses can that subnet mask support? So the host bits for the subnet mask is 5. So 2 raised to 5 minus 2 is 30. Next, can you subnet the remaining subnet again and still support this subnet? The answer is yes. What are the network addresses that would result from the subnetting? Again, this is gained from the IP address calculator. 192.168.33.192/27 and 192.168.33.224/27. Use the first network address for the subnet. So, there. Next, determine the third largest subnet. What is the subnet description? BR2 IoT LAN. Since among the remaining subnets, this has the highest number of hosts, 5 hosts. How many IP addresses are required for the next largest subnet? The answer is 5. What subnet mask can support that many host addresses? /29. How many total host addresses can that subnet mask support? So it has a host bits of 3. So 2 raised to 3 minus 2 is 6. Can you subnet the remaining subnet again and still support the subnet? Yes. What are the network addresses that would result from the subnetting? So the answer is 192.168.33.224/29, 192.168.33.232/29, 192.168.33 192.168.30.29 and 192.168.33.248/29. Use the first network address for the subnet. So this is the first network address. Next, use the second network address for the CCTV LAN. So the number of host bits is 4. Number of hosts. Number of hosts is 4, but we will use 3. 2 raised to 3 minus 2 is 6. So 192.168.33.232/29 to 192.168.33.240/29. Next, use the third network address for the HVAC C2 LAN host. Number of hosts 4, but we will be using 3. 2 raised to 3 minus 2 is equal to 6. So the result is 192.168.33.240/29 to 192.168.33.248/29. Next, determine the fourth largest subnet. What is the subnet description? Subnet description is BR1-BR2 link. Next, how many IP addresses are required for the next largest subnet? 2 hosts. We didn't use the BR2 and BR2 CCTV LAN and BR2 HVAC C2 LAN since we already declared a network address for these two subnets. So the remaining would be BR1, BR2 link. So next, what subnet mask can support that many host addresses? /30. How many total host addresses can that subnet mask support? So the host bits is 2. 2 raised to 2 minus 2 is 2. Can you subnet the remaining subnet again and still support this subnet? Yes. And what are the network addresses that would result from this subnetting? So the results are 192.168.33.248/30 and 192.168.33.252/30. So use the first network address for this subnet. So this is the first network address, this one. So we would use it as the network address for this subnet. Okay, next. Use the information that you obtained in part 1 to fill the following tables. Okay. So first, for BR1 LAN. There. Number of hosts needed, 40. Okay, here. So, first, the network address. It is 192.168.33.128. This one. And for the first host address, we will just add 1 to the last bit. So it would be 129. Same, but the difference is the last bit is 129. And for the broadcast address, the last one, we will just subtract 1. So it would be 192.168.33.191. Next, for the BR2 LAN, number of hosts needed 25. So let's go to the, okay, here. So for the BR2 LAN, number of hosts needed is 25. And the network address is 192.168.33.192/27. So we would just add 1, so it becomes 0.193. And for the broadcast address, we would use the second network address calculated, and we would subtract 1 from it, so it would become 192.168.33.223. The same goes for the remaining subnets. So for example, here at BR2 IoT LAN, we'd go here, and the number of hosts needed are 5. So for the first network address, it would be 192.168.33.224/29, and we just add 1, so it becomes 225. So for the broadcast address, we would use the second obtained network address, and we would subtract 1, so it becomes 0.231. Next, for the CCTV LAN, it requires 4 hosts. Number of bits would be 3. So it's the same. So the first network address would be here, CCTV LAN here. So we would just add 1, so it becomes 0.233 from 0.232. And for the second obtained IP address, we would just subtract 1. So it becomes 0.239. So next, for the HVAC C2 LAN, so the first network address would be 0.240/29. Network address, first host address, we would add 1, so it becomes 241. And for the broadcast address, we would subtract from the second obtained network address, So from 248, it becomes 0.247. Now, lastly, for the BR1, BR2 link, it requires 2 hosts. And from the obtained network addresses, this would be the used network address. So we would just add 1 for the first host address, 248 to 249, and after that, we would use the second obtained network address here, and subtract 1 from it, so it becomes, from 252, it becomes 0.251. For the step 7, complete the device interface address table. Okay, so for BR1, the interface would be G000, and the subnet mask, this is obtained from there. So for BR1 G00, the subnet mask is 255, 255, 255, 252, since we would use the BR1, BR2 link, or /30 here, which is device interface, and the IP address. So for the IP address, it is here. The IP address, we would use the first host address. So 192.168.33.249, and this would be the IP address. Next, for the G001, it uses the 40 host LAN. So for the 40 host LAN, it is BR1. The first host address would be 192.168.33.129, so it would be the used IP address. And since it has for the BR1 LAN, it uses a /26 subnet mask, which is equivalent to 255.255.190. Next, so for BR2, the IP address used is 192.168.33.250, and the subnet mask is same with here. We just added 1 from the first BR1 BR2 link interface, so it becomes 250, but it still is the same subnet mask, and that is it as the device interface. So next, for BR2, G001 is the interface, and for the device interface, it is the 25 host LAN. Wait. So this is the one that uses 25. There. This is the BR2 LAN. The subnet mask is /27, which is equivalent to 255.255.255.224, and the IP address is the first host address, as in here for the BR2 LAN, this one. So we would be using that one as the IP address. So okay, so now let us move on. I will try to build the topology zone here using packet tracer. So here, okay. So now let us put in our workspace the required components for this topology. So it requires, I will use a 4331 router and a 2960 switch. There. So let's arrange it, and I will use a copper straight through cable. So first, go to S1 and click FO, Fast Ethernet 505, and go to Gigabit Ethernet 001. Next, for router 9, which is BR1, go to Gigabit Ethernet 0 and connect it to BR2's Gigabit Ethernet 00. After that, go to BR2 and click Gigabit Ethernet 001. And for the switch side, for S2 side, use the Fast Ethernet 05. So I'll just arrange it. So I'll try to rename it so it is not confusing when we're looking at the name of the components. Okay, so now the first step is we would go to BR1 and go to CLI. So enable and config. Okay, so for the first step, assign the device name for the address. So we will type hostname BR1. After that, disable DNS lookup to prevent the routers from attempting to translate incorrectly, though they were host names. So I'll type no IP domain lookup. After that, assign class as the privileged exec encrypted password for both routers. So I will type enable secret class. Next, assign Cisco as the console password and enable login for the routers. So line con 0. Next, assign Cisco as the VTY password and enable login for the routers. So line 0. Password Cisco. Next, encrypt the plain text password for the routers. So this password. Service password and there. Next, create a banner that will warn anyone accessing the device that unauthorized access is prohibited on both routers. So put banner MOTD authorized access only. Next, configure the interfaces on each router. Assign an IP address and subnet mask to each interface using the table that you completed in part 2. So this is the table for part 2 here. Okay, so first, interface G0 00 G0 and we will set the IP address 192.168.33.249 255.255.255.252. And after that, interface G001 and we'll type the IP address 192.168.33.129 255 192. And after that, configure an interface description for each interface. So exit. So again, interface G000. So description. BR1, BR2 link. Next, interface G001 description. This is connected to S1. There. So exit again. So now we will activate the interface. Interface G000. No shutdown. After that, interface G001. No shutdown. So for BR1, we will save the configurations. Copy running config start up. Exit. Copy running config start up config. Okay, so now that we are done with our first router, let us now move on to our second router. So we will just repeat the steps I have shown earlier. Okay, so again, enable config. Right, so host name is br2. Next, IP domain lookup. Next, enable secret class. Next, line com 0.
You getting high already? It's just 2 o'clock.
It's that late?
You smoke too much of that shit. That shit's gonna rob you of your ambition.
Not if your ambition is to get high and watch TV.
Stop faking jacks. Stop faking jacks. Brothers who fake jacks get laid on their back.
So now that we are done with step 2, part 4, VR2, we configure the IP addresses. So first we will go to the interface, G0, 0, and enter the IP address for BR2. So after that, let's see, config your interface description. Interface 0. Connected to S2. Since BR2 is connected to switch. After that, exit again. Interface G0, 0, 0. No shutdown. And after that, interface G0, 0, 1. No shutdown. So after that, just exit and exit again. Copy. This would be the part where we save the configurations. Copy running config. Start up config. Okay. Now that we are done, you could see that there a connection is already established between the path link. So from switch 1, it's connected to BR1, and BR1 is connected to BR2, and BR2 is connected to switch number 2. Okay, so now we would test the connectivity from BR1, ping BR2's. Okay, so we would go to BR1. Okay, so press return to get started. So the password is Cisco, and from here we would ping from BR1, ping BR2's G00 interface. So this would be the IP address for G000 interface of BR2. So ping 192.168.33.250. So success rate is 80%. So we will try again. Ping 192.168.33.250. So now the success rate is 100%. So meaning there are no wasted packets that were sent through the ping. So next, BR2, from BR2 ping BR1 G00 interface. So exit. So the password would be Cisco, and ping BR1's G00, which is this one. So ping 192.168 192.33.240. The success rate is 100%. So that is it for our experiment 7. We were able to design we were able to design and implement a VLSM addressing scheme. So from the computations, we were able to create a table, and then from the table, we were able to implement the IP addresses and the required steps using Cisco's packet tracer.